Hi there, and welcome to this lesson on Further Pure Mathematics 1. We're on Chapter 7 and looking at 7.2, Sums of Squares and Cubes. We'll be looking at 4 formulae, the proofs of which are in the next chapter. The first 2 you've already met. If you have the sum from r equals 1 to n of 1, that is n. If you have the sum from r equals 1 to n of r, that is a half n into n plus 1. Now, progressing from there, for r squared, the sum is equal to that formula, and for r cubed, the sum is equal to that formula. It is worthwhile noting that the sum for cubes is a quartic, the sum for squares is a cubic, the sum for a linear term is a quadratic, and the sum for the number, constant 1, is a linear term. Okay, have a go at doing this using the formula for r squared. No tricks, no catches. Pause the video, then come back to me. Okay, so that's what we're doing, and that is the formula that we're using. All you have to do is substitute 30 into the formula. That gives you a 6 into 30 times 31 times 61. Throw all of that in the calculator, and you should get 9,455. Have a go at example 2. It's using the formula for r cubed, and you're going to have to split it into 2 bits because the sum starts at 10. So using the method that we used in the last lesson, have a go at that. Pause the video, then come back. Okay. So first of all, splitting it into 2 parts, you'll find all 30 terms and then take away the first 9 terms because we don't want them. And then that's the formula we're going to use. And all we do is use it twice. So first of all, we substitute 30 into the formula, and then we substitute 9 into the formula. And from then on, it is just calculator work. That is, well, it's the same line again. And then after you put it into the calculator, you should get that. And then finally, for the answer, you should get 214,200. Okay, example 3. I'll let you have a go at this yourself. It's a little bit more fiddly because we're not using numerical values as the limits. Okay, have a go. Once you've tried it, then come back to the video and I'll talk it through with you. Okay, so it's r squared, so that's the formula that we're using. We need to split it up into 2 parts. So first of all, we'll find all the terms from 1 to 2m, and then we'll take away the ones that we don't want, which in this case is the terms from 1 to m. 1 less than that value. That's always what you're using with this. Substituting 2m into the formula, you get that. And here we're just changing n to m, we're substituting m into the formula. And you should get that. Now, the reason for the different colors, with this type of question, the best way forwards at this moment is to factorize straight away. Don't be tempted to multiply everything out and then collect all the terms together. It would probably work, it's just an awful lot more difficult and takes longer. You know you're going to have to factorize it because it says in the question you're going to. That's what you're heading towards. So the very first moment you can do so. Now, in this case, 3 things, 1/6, m, and 2m plus 1 are common to both terms. So we take those outside the brackets. And then inside, we'll have 2 into 4m plus 1 minus m plus 1. We multiply these out and collect these together, and it takes you straight to the answer, which is what we were hoping we would get. Okay, example 4. Again, I think I'll just let you try this yourselves, first of all. You're going to have to split it up into 3 bits and head on from there. But I'll let you have a go. Pause the video, then come back to me. Okay, so splitting it up into 3 bits, you'll get the sum of r squared plus the sum of r. Take away 2 times the sum of 1, and then you've got the 3 standard forms, which allows you just to use the 3 formulas. So for the first formula, we'll get that. For the second one, we'll get that. And for the third one, 2 lots of n. Again, at this point, we factorize. The n is easy to see we can take out. Normally, with this sort of thing, it's the smallest fraction you'll be taking out. Tends to make things work easiest if you do that. So we'll take out a 6th n. That gives us n plus 1 times 2n plus 1 here. 3, because 3 times a 6th is a half. And 12, because 12 times a 6th is 2. And then at that point, you do just have to multiply out the brackets, collect all the terms together. When we do that, we get a quadratic. You'll notice there's a common factor of 2. That's useful. We're supposed to be having a third outside the brackets. We've got a 6 at the moment. If we take 2 outside the brackets, then we will have a third. And then inside the brackets, we get a simpler quadratic. You should immediately be thinking, does this factorize to give me that? If it doesn't, you've probably made a mistake. In this case, there's no problem. If you factorize n squared plus 3n minus 4, you do get n plus 4 times n minus 1. So we do arrive at the answer. Part B to that, I'll let you have a go at this first. It's asking us to use this result, the result that we've just proved, to find the sum of this series. I'll let you have a think about this. Pause the video, then come back to me when you've done it. Okay, if they ever do this, if they ever give you a result and say use your result to do something, you know for a fact there is going to be a relationship between this series and the sum that we had at the beginning. Sometimes the relationship isn't that straightforward. Now, in this instance, it couldn't be more straightforward. All they've given you is that series where n is set to equal 20. If n was 20, you'd start off with 0 when you put 1 in there, and you go all the way through to 418, which is the series they've asked us to find the sum of. Now, the moment you notice that, you're allowed to use the formula. So all you have to do at this point is substitute 20 into the formula and work out the answer on the calculator. That's what you should get when you substitute 20 in, pop all that in the calculator, and you get 3040. Okay, this is the last example. I'll talk you through the beginning of it, and then I will let you try and finish it off yourselves. If they give you something like this, you might be tempted to think there's some clever, crafty way to do it. If there is, I don't know what it is. What you actually have to do is just multiply out all the brackets, get 3 separate terms. Once you've got those 3 separate terms, you then write down 3 separate terms, 3 separate sums. So you have 2 times the sum of r cubed, 5 times the sum of r squared, and minus 3 times the sum of r. And from then on, you're just plugging in the formula and trying to plow your way to the answer. I'll let you try and do that. Good luck. I don't go through it. Once you finish that, then pop to page 122 and exercise 7b. Okay, that is the end of the lesson. Thank you very much for coming along. And I'll turn it off now.